Hello everyone, welcome back to our architecture series. My main idea with these videos is to teach someone to reach or to be an architect or guide the person, because there is no, let's say, teaching or a set of videos or course that you can take. Now I'm an architect. It doesn't work like that. It's experience, it's sensibility, it's to be aware in the meetings about everything that happens. It's to have a vision 360 degrees, meaning you should understand what's happening above, below, on the sides, what are the implications of some decisions. So I would say that probably 60% it's management and 40% technical. Of course, we have to follow all the trends, understand to understand the technologies, the new technology, how to apply them. But we also have to understand legacy technologies, because we have to make a lot of trade-offs. And in my previous video, I approached that part. Today, I want to approach someone that probably it's a developer or it's a senior and still develops, and that's okay. I am an architect and I still develop and I like it to do it. But my video today, it's about, okay, let's see the difference between the vision of the architect and the vision of a developer. And I say developer, it can be a very high skilled person with 10 years experience in developing that sometimes do some solution design or maybe is doing some solution design. But I want to everyone understand the difference between how an architect looks into a solution or a problem and how a developer does the same thing. And we'll see the difference. And during these videos and the slides, maybe you will start to understand if you have a developer vision or an architect vision. And if you want to be an architect and you have a developer vision, of course, you should start to reframe the way you look into things and problems and how you communicate and involve with all the stakeholders in a project. So I have this agenda. It will be the subjects that I will address in this video. So first introduction, of course, the invisible beginning that sometimes developers don't see, but the architect, it's always working. What is the difference between architecture vs code? Of course, it's not a comparison side by side, but it's the vision about what an architect does, how a code developer looks into things, and let's compare it. We'll talk a little bit about timelines of a future project. Usually, what is the timeline when the architect is involved in your developer, in your project, or in a new feature. Then one of the most important things, which is the mindset shift from a coder to architect. So you are a developer and want to be architect, and I will guide you here in some of these topics. Of course, this video, after this video, you will not be able to be an architect if you are a developer. I have in my, let's say, to-do list dozens of videos about architecture. Some of them will be theoretical, like this one. Other ones will be, let's study this architecture style, let's study this system design, what is the CAP theorem, what is these laws that you should understand, how to approach when you have multiple APIs and multiple microservices, how should they communicate, what if there is external systems, how you should decide what is the best pattern and why, and we'll see things like that. So in my future video, so it will not be a theoretical course, let's say, let's call it course, this set of videos, but more about learning things. And when you learn all these things, your mind will start to see things differently, so you will be able to think more like an architect, let's say like this. So I would say that not only this topic, mindset shift from coder to architect, it's important, but all my videos will be about this mindset shift. Unless you are just an architect and you are here to gain some knowledge, or maybe to have a different perspective, or maybe I hope to agree in some of my perspectives on things. So then we'll talk about core architectural questions and ask early, because one of the most important things about an architect is to make the right questions. Okay. Stakeholders to engage early. Stakeholders, it's really important on the architecture. Define system boundaries before code, and this is probably the most important from the technical point of view of an architect. It's the boundaries, because the boundaries imply communication, protocol, security, authentication, authorization, formats, a lot of things. Decision framework, architect decision records, and way to document architectural decision. There are others. I will address this one here today. Maybe I will create a specific video to create one from zero, but I'll promise that you will have at least 3 or 4 slides talking about this. I think it should be enough for you to start to use them if you want, or start to read them, or start to maybe even start to propose in your company if you are not using it. And I will talk about some tools to support early architecture. It's not exhaustive, just they are just examples, but it's quite nice to. And I'm a person that likes to for someone to tell me, okay, these tools exist and can you accomplish this? And sometimes I have good surprises, so it's always welcome. So introduction, the invisible beginning. So most developers think architecture begins with frameworks or coding decisions. Architects know it starts long before. Meaning, as an architect, I can say to you, my first thought when there is a problem, it's not developing, how it will be implemented, what is the language, what is the technology that I will use. I'm more concerned about other things. First, is architect is a series of strategic decisions made under uncertainty, because we don't know what will be the right approach or the right solution. We can take help from decision frameworks. Some of them I created videos about first principles and things like that. So we want to make sure that we understand what we have and what we can apply. That's one of the things. Strategic decisions are also related with the business strategy of your company. What does your company want to accomplish with this project? And this is the most important thing. Most of my decisions in most of my meetings when I start a project in a company, it's understand what they want. What is the purpose of this? What is the business? What is the most important stakeholders? What they expect for the customers to look when we are developing the application? And this is the first mindset shift that you should have, because you should start to understand how to talk with the stakeholders. The technical part comes later, because the technical part will be to apply all these, the response or the answers that we'll have for the questions that you should make to all the stakeholders, so you can align with the strategy of your company. And it defines how a system behaves, evolves, fails, and scales. That's another thing that always is in my mind. And coding is just the implementation of those decisions. Coding is just, okay, we already decide, we have these constraints, we have this money, we have these people, we have these technologies, we have know-how on this, so let's code like this. It's not, I have these technical people, I know a lot about this language, let's start to implement a generic solution and then we adapt later. No, it's the other way around. So architecture versus code, there are more than this, but probably these ones are enough to understand. So architecture about high-level structure, code is low-level implementation. Architecture defines boundaries and responsibilities. It's one of the things that I always ask when I'm developing a system. It's about ownership. So people say, oh, we should have a model or this application to do this. We are integrated this model with another application from other department or other company. And my question is always, who owns what? So I have a feature, who owns what? Which of these systems will control the decisions? That's one of the most important things. You should understand the domain of things. What are the boundaries of things? Not only technical, but even from the business point of view, because that will have great implications, for instance, on security. Roles, how you should apply the security, authentications, authorizations, and things like that. So it's really important this. Of course, the code will implement the behavior, but it should be defined at first, where is the boundary. For instance, you can have 3 microservices that one authentication serves the 3 services. But if these microservices belong to different departments and they have sensible information for each one, maybe we want a kind of a single sign-on, but the authorizations will be very specific for the microservice, or even or probably you want 3 different authentication mechanisms or the same mechanism but in 3 different services, because the users and the roles are completely, let's say, split or segregated one from another. And I'm participating, including in some of these projects right now, because we have databases and systems that belong to external companies that want to manage their own portal. They don't accept the same database and the same code to be shared with the other company, even if we promise that we split things and it's not possible for the others to see. They really want physically to be split from the others. So that's always important to understand what are the boundaries, and not only logical boundaries, but sometimes even physical boundaries on the system. And of course, architecture involves trade-offs and risk. This is something that we'll always hear in almost every video about architect. It's all about trade-offs. You want something in pro of another, or for the sake of the other. And code executes business logic made under uncertainty. The architecture And of course, when you code, you need a real scope with a real details about a feature, something that the architect doesn't have all the time. So the architect defines what's possible, and code defines how it's done. That's completely different. So for a project, I would say start always with architecture. Even if it's a small project, try to understand the constraints around the architecture and start from there. Understand first the what, after the why, of course, then we'll do the how. Don't start with the how. Okay. This is a timeline, just an example, is not supposed to be very, very real, but usually so you understand the phases in a regular project when there are architects. So you have a kind of a discovery. Sometimes there is some pre-coding. Okay, it's not coding the project, but probably, and I do this a lot of time, which is create a proof of concept. Maybe I want to integrate some security with other systems, multiple authentication mechanisms. Let me develop something to check if it works or not, and what will be the challenges during the path. And usually do some pre-code. It's not coding for the application, it's coding to make sure that we understand better the future implementation, and you can guide the developers and the teams to implement the way that it should be implemented. Then there is some problem framing. We start to frame the project, start to understand better the boundaries. So we have initial architecture. It's never final, this initial architecture. We have a document. We start and then we check, okay, maybe we cannot use this approach because maybe you don't have people for this. We don't have know-how. The time to market doesn't allow these kind of things. We cannot use that system because it takes a while to understand it. Maybe we should go simple now. So it's the initial architecture. Then there are some architecture reviews. So we try things and then we return again to the architecture. And then when we are comfortable with the first version or a minimal viable product, we start to code. And then there are the usual suspects like code review, testing, performance, deployment, and then the post-deployment review. But of course, this is a cycle. At some point, probably we'll came here for the architecture review and start to review things. Mindset shift, as I said previously, from code to the architect. If you are a coder, or maybe you are not, you want to guide your coders to, let's say, increase their knowledge or being more senior in your company. So if you are a developer, don't ask, what code should I write? That's the wrong question when you start the project. Is what decisions must be made before I write any code? It's again the what, not the how. So what decisions should be made? What is important? How the features? What will be the systems? How do you what type of architecture will do monolith? Will do microservices? Why we are doing that? Because that will have great implications when you are writing the code. Even for instance, if you want to introduce something like observability and things like that, your code should be able to be monitored. They should be configured for that, and maybe that will make you change even the language or the framework that you are accustomed to use, for instance. So key mindset shift, so from individual work to system thinking. So you start to think about systems, not individual work. From requirements to constraints. An architect doesn't have requirements. Okay, it has some requirements, of course, but most of the time the decisions will be more about constraints. Because when someone says, okay, we need to do a website, and people think, okay, I'll go with React or Angular, I'll create an API, I will create a load balancer, I put behind a few containers, so you have load balancing, then I have a database, let's decide which database do I have. This is the first thing. It's a system thinking but the problem is that there are constraints. It will be in the cloud or not? Do we have money for that? How many users will we have? And some of the things start to constrain, and maybe I cannot use this database. I don't have people for a NoSQL database. I'll talk it was the best one. I have to train someone, but we have to deploy this in 2 months, so I cannot, or maybe I want to hire someone. So you have all these decisions, and then the constraints appear. And this constraint will start to shape your requirements from the architecture point of view. And after you have these requirements, then you start to do something or deploy something for the developer. And maybe you go to the developer and say, let's start this simple model, develop it, and let's see how it works, how much time it takes to develop a feature. Okay, it takes 1 week. We have 12 or 15 features similar to this one. Okay, 2 months. Okay, maybe we have to cut something or some complexity here. Maybe you cannot go with this feature on the first version. You have to take all these decisions. Okay, then you go from tools to trade-offs. To take good decisions, considering the constraints, you should make trade-offs. you say, okay, the best database will be something like a graph database like Neo4j, which is quite great for some scenarios. But yeah, but you cannot use it. We don't have money. We don't have people to handle it. We have to gain some know-how. We don't know how to scale this. Okay, can we implement this using a Postgres or something with a, I think Postgres has a kind of a graph model over it because it's SQL, it's just a model over it. The queries will be a little bit different, but we control better and we don't have to pay the license because it's Postgres. Maybe we have to pay some processing time on a cloud, but that's it. So you have now the trade-offs. And for short-term delivery to long-term evolution. A developer is, okay, I will present after this sprint, I will have this. An architect doesn't work by sprints. Can help to implement some features and try to commit to say, okay, in the next 2 weeks, for instance, I will implement this, but it doesn't work. For instance, sometimes when I'm in companies, there is a Scrum board for the developers and for the teams, but for the architecture is a different one. It's not a Scrum board, it's just a Kanban board. We don't have a specific time. Of course, we talk with the teams and we say, okay, I will address this next week. I should have something for you next week. But we don't say, okay, let's put it on this sprint. It's not. It doesn't work like that because it's a long-term evolution. We have to understand that to implement this architecture decision, I have to make this first and give to the teams. Then I have to wait some time to check if it was a good decision or not. Maybe I develop a proof of concept on the side to make sure that I have an alternative if this one doesn't work, and so on and so on. Okay, it's a completely different mindset shift. Okay, core architectural questions to ask early. There are a lot of questions that you do, and as soon as you start to gain some experience, you are working as an architect, you will see that you have a lot of questions. Most of them arise when you are in the meetings. It's not that you have a list of questions. I don't have a paper with 100 questions that I want to ask. That will be bad for everyone. If I ask them, okay, I have these 50 questions to ask you on this first meeting, people say, oh, really? Okay, just some of them, they arise during the meetings, but when you start to listen, you start to see that there are some questions that you have always in my mind, of course, depending on the context. For instance, what problem are we solving? And this is one of the most important questions. What do we want to accomplish? Who are the most important stakeholders? It's the end customer, it's integration with the team, it's the security. What is the big problem? Because all the decisions will be taken after you understand this one. Who are the user stakeholders? And this is really important. Who are the stakeholders? It depends on the project, but you do things for the stakeholders. So it belongs to the mindset shift from developer. The developer doesn't care much about the stakeholders. I remember talking with a lot of developers when they're implementing feature, and sometimes I ask them, okay, what this will accomplish from the business point of view? And they couldn't say. They say, I know, they just asked me to create a column, add a specific method in the code, and that's it. They say, okay, but you will never be an architect like that. You have to understand what is the purpose of what you're doing. Okay, so you have to understand what is the problem and who will see what you are doing. What implications will this have for the end customer, for the DevOps team? Maybe you need some configuration. You have to keep any secret on the code and things like that. So there are a lot of people that when you are developing, you should be aware. And of course, from the architect point of view, it's one of the most important questions. I had to do a review on a code from an external company, and one of my first questions were about this. Were about, okay, where do you keep the secrets? You have configuration files. Are they encrypted? Where are they? Because it was an application to be published to the public, so I don't want to be public passwords available to them, right? So what are the failure modes? How it can fail, and what is the risk of failing? What can we do about it? What are the scaling needs? We have to project this, create a nice chart, say, okay, we expect 1,000 users for the first 3 months, and then probably we expect an increase, let's say to 10,000, then 100,000, something like that, depending, of course, of the project. But understand, and when this happens, what do I have to do? What change do I have to put on the architecture? Of course, I have to prepare an initial version of the architecture that will allow this scale and these changes during along the time, right? So what are the regulatory security constraints? This is really important. Nowadays, everything is about GDPR and I know California Act. I think there are 7 or 8 about privacy in the world. Australia, California, I think Canada, maybe Brazil. Probably China also has, at least from the applications that I'm involved with. Sometimes these names appear. In Europe I had to make sure that one of the applications were compliant with the GDPR, and it's not easy in most of the things because sometimes you have to remove data. And did you prepare your architecture and your solution to remove data at request of the end user? Sometimes people forget this. They just develop and later say, okay, then we implement later. You say, really? And can you? Because you process all this information, you archive, you do to some backups and things like that. How you make sure that you can clean all the data? And if there is an audit on that, can you show you that this user doesn't exist anymore? There are a lot of things related with regulatory and security. I will observe the system in production, which is called observability. I initiated a series about observability. You can check my videos, but it will be about how can we make sure that, let's see, put it another way, how can I observe the system, what happens internally of the system from information that I can expose externally, like traces, logs, and metrics, and so on. And what will change often, what must remain stable. And this is quite important, as you I think understand quite easily and quite fast the why, right? If something can change a lot, we will implement a lot of features. Maybe it's a difference between, will I go monolith, microservices? Maybe I want an event architecture. Do I want to plug things without change the others? Maybe I want a loose couple architecture. So there are all these decisions that you should take into consideration earlier. Okay, so these are the questions to ask earlier. So stakeholders to engage earlier. Product owner, okay, it's the owner of the product, vision and priorities. You know what is best to develop now, what should be the first version. Domain expert, you need people to explain to you the business, of course. And of course, DevOps, operational impact. This will be deployed. You should be able to have people to understand what will be deployed when there is a complaint, how to check the logs, how are they managed, things like that. There are a lot of things behind DevOps. DevOps, sometimes it's when you are developing architect, you don't think too much about it, but it's quite important because after the system is running, if someone has a problem, who will receive the call? Who will check? Who will troubleshoot? Who monitor the system? Who does make sure that the system is up? Do we expect someone to ask us or phone us and say, hey, your system is down, your server site is down? Of course not. That's why we need DevOps. Security, risk assessment, that's crucial nowadays. Of course, everything about security, where do you keep the secrets, how much time, how people do those authentication. In case of a breach, how fast can you change? And let's say reset everything and make sure the users have different passwords now, things like that. And of course, the business leader for strategic alignment. This is one of the persons that I talk mostly. When I'm in a project, I have to understand what is the strategic, what they want to accomplish in the next 12 months, 6 months, so I can take good decisions about architecture. So architect is not technical alone. You can say this is a kind of a social technical, okay? And I think it's a good word for an architect. Okay, let's see more in practice this. I start with a simple diagram that I think everyone understands. And of course, before coding, one of the most important things is to define the system boundaries. When we see this, you have this service A with a, let's say, 3-layer architecture, and there are 2 types of boundaries here. There is this service 1. This can represent an application, can represent in a cloud or maybe a data center or something. And you have external service B, which can be, again, a microservice or a service or an API that you will call remotely, or even can be another company that we are integrating. But important is to understand there is this boundary here, and there are internal boundaries. From the external boundaries, there are a lot of questions that you have to ask. Okay, I am to talk with whom? Do I need authentication? Who does the authentication? What if I am an API calling this one, and this is for an external company, how they provide me the authentication or the authorization token? How much time this will be valid? What protocol will be using? In case of fail, who is the responsible? Who is the, let's say, the service responsible to retry, or we just ignore, okay, it failed? Let's say, imagine that you have a system that should produce something now, but it was not possible to send this there. Should I create a queue here? So you start to understand this boundary. It's quite important because it talks with the outside, even if it's an application or a cloud or whatever, and it should take in consideration everything that it's outside. It's like if you think on your home, one thing is how you protect your house, the door, the locker that you have. Other thing is how you protect the rooms inside your house. Probably you have lockers, but they are not as, let's say, reliable or strong as the one that you put outside in your of your house. And even talking or the communication, it's different. When you're talking, you don't go to the street or to the door talking out loud about your private things, right? All your neighbors will listen. But inside your house, you talk freely, and the same concept somehow applies in this case for these boundaries, if you want a kind of a metaphor. We'll study more this into detail in future videos, and we'll be applying patterns and specific technologies, how they work and we can be applied. But from the technical point of view, I think you start to understand why it's important, the boundaries, so who talks to whom, who should be internal or external, how will service interact, kind of protocols and things like that. So you need a kind of a decision framework. So architect took a decision, so how everyone knows about what is decision. First, talk with the people. I would say don't write a document and send by email. Talk to them. Sometimes 10-minute talking is better than one reading the document. It doesn't mean that you don't have to write a document, but talk to them first. I always prefer to talk rather than write. I write later, or maybe I start to write, talk to them, and then formalize using a document. I have been in both companies. I was in a company that I really had to create a formal document, discuss with other architects, and then show to the developers. And at first I just created documents, but after a while I start to talk with the teams first, so I understand better their problem, what they expect. I was preparing them for the solution, say, I will introduce this new thing, you will need this protocol, you need to open this door. I even work before with the DevOps networking team, so they were prepared for my decision. And when I took the decision, was approved, they already prepared for that. Or maybe they can say, you cannot take that decision. There is a constraint on the network, you cannot communicate with that server. And that will change my, so if you can speak with the person first, try to understand the constraints before, like I said previously in our previous slides. Constraints, it's one of the things that always follow with the architect. But there is this kind of architect decision records, a lot of different formats that you can use. But I like the architect decision record. And I will create a specific video just to explain this into more detail, but I will explain here in 2 or 3 slides how you can create one. And I think it's you can even use it not for architect but solution design. The main idea is just create a markdown document, quite simple, with a title, a status meaning that it's approved or not, a very simple state, a context meaning what we want to accomplish, the decision that was taken, and some consequence. Maybe there is technical debt or something like this. Okay, I took this decision, but I know this doesn't work well, doesn't address yet this problem, and we took this decision. We know that are not the best, but we had constraints on money, people, or something like that, and I had to create this decision. So use ADRs, architect decision records, to prevent rediscussion of settled issues, meaning that this document will be approved. So later, if I don't agree, yeah, too bad, we had your time. That's as simple as that. You have at some point to establish, to say, we are committed to this. Maybe there will be a different, now it's not that you don't agree, propose a different solution, because not agreeing is quite easy, but propose a different solution that solves the problem better, that's a completely different challenge, right? So to onboard new team members quickly so they can follow the sequence of decision records. I don't explain it into detail, but usually they have a kind of a number, or sometimes I even do that. You can include these documents in the project in a folder called ADRs. So every time you do a commit, you have a history of these ADRs there. But there are people that prefer a different repository on Git for the decision records, but then you have to create a folder. Maybe you have the decisions that are specific to an application. You must have a good title so people can find quite easily the document. That's a trade-off that you should depend on the project, the dimension of your company, and so on. But I like the structure of document. It's really simple, and you can follow quite easily, and to communicate trade-offs and reasoning with stakeholders, because this is not a technical document. It's a document to say, we took this decision. We will be using Neo4j database, for instance, because of this, and this. What do you think? Technical people, dev people, DevOps people, everyone is prepared, network people, sellings people, and so on. Okay, let's see a step-by-step example. Imagine that you want to put some authentication strategy. Again, it's just a simple example so you understand how to fill one of these documents or read one. The structure is not rigid. I saw people with different things here. Usually these 4 or 5 are always the same, but sometimes there are people like to add others. If there are communications, networking, security, sometimes they put specific chapters for that, and it's okay. It depends. It doesn't mean that you decide the format, and all the ADRs should follow this format. This is a document to communicate and to establish a commitment. That's it. It's not something to be automated and processed that should follow a strict structure. Okay, remember that we do these things to help us, and that's it. We don't have these things, and you have to follow them. It's the other way around. You use to help us, not our side to help the tools. Okay, sometimes people don't understand this concept, but I think it's quite simple to follow. So identify the decision. How should we implement user authentication in your web application? Okay, this is the title that we want. Maybe some of the things, but of course there are others. Document context. The app will serve internal employees and external clients. So it's quite important to understand what is an authenticated strategy. Since if it was internal, maybe a simple thing like username, password serves. But if there are external, maybe they already have emails. Maybe we want something like single sign-on with Google Workspace, probably because external clients, they are already using Google. Okay, this is the context of our decision. Time to market is critical, so we don't want to develop from zero and something that already exists. Okay, and security should be regulated. So I want something formal. We are from the context. It should be easy to take a decision to say, okay, it's something that should exist, well proven in the market, and where we can apply all these requirements. So we record the decision. Let's say we'll use OAuth with Google Identity as the primary authentication provider. For internal users, SSO will be enforced. External user, you will use the email and one-time password. For example, you can establish this our decision. And of course, there are some consequences with that. We say fast integration to Spring Security and existing libraries. If you are using Spring, for instance, centralized identity management, which is a good thing, but okay, requires handling token refresh and storage security. Should be okay, it's something that we should do. Additional complexity if migrating away from Google later. If you want to migrate later, okay, maybe it will be hard to do it. And this is where, when previously I talk about, okay, talk a lot with your business leader because he knows the strategy. Do we want later to move from Google or not? What is the strategy of the company for the next 1, 2, or 3 years? Okay, so you understand if this is a good solution. Maybe you don't want to use Google to say, okay, no, we cannot use Google because later in 6 months, because you have an agreement with Microsoft and we don't want to keep with Google. Maybe we have to find another solution. Okay, and maybe you can say, okay, so we go Google now, integrate with just one company, but at the same time, we are already starting with a Microsoft in a different versioning, and later, and we start to check how can we migrate this one, but for the others, we already go with Microsoft, something like that. But it's, as you can hear, it's about strategy. It's not about coding or technology, it's about strategy, okay? They are output sample, it will be something like this. Of course, usually this document, it's a little bit bigger, but it doesn't mean that it needs a lot of pages. Markdown, usually, my documents, if I put in Word, they don't have more than 2 or 3 pages in Word if you want to export Word. Usually I do Markdown, but from the number of words, I would say 2, 3 pages most, and most of them is usually just 1 page. It's enough. So title, it will be this one, accepted, context, the decision, and the consequences that we decide to put here. So later when someone arrives to the company or asks, why did you take this decision one year ago? It doesn't seem a good one. Okay, but it's always about context. It's when I usually talk with people and sometimes we discuss things that are not computer and say, okay, people 2,000 years ago, they start to talk about people 2,000 years ago, but they don't have the context. And they say, okay, they were very barbarian and things like that. They said the ethic was not the same. Yeah, you see, but because in that time they were trying to survive. They don't have houses like us, hygiene like us, a lot of things that we have for granted. They don't even think about it that it could exist. So their way of living was different. They have different constraints and a different context. And when this ADR was created, there is this context. We needed this at the time. Probably it's not valid anymore, but at the time the context said it was this. So the decision was this one. So every time you go to a company, don't criticize if you don't like the solutions because there were a reason for that. Time, people, sometimes, and I'm almost sure that the reason was not technical. It was a different thing that at the time made complete sense to take the decision they take. But I see this again and again. People arrive into a company. Okay, who had this idea? Yeah, but probably in 1 year. And usually when I see these people, I say to them, yeah, when you leave this company in 1 or 2 years, or maybe even you are still working here, maybe someone will arrive and we look into your decisions. Why this guy took this decision? Okay, because at this time you thought that it was the right decision, considering the context. Okay, tools to support early architecture. Okay, if you want to pause and check this, it's just to give you ideas. They are not the right tools. I use a lot of different tools than these ones. I use these ones most of the time, and I use other tools also. Depend on the project, depend a lot of factors. But usually it's quite popular, the C4 diagrams. That's why it's here. There are other diagrams for architecture. For instance, Archimate. I work in a company for 2 years where we're using Archimate, UML, and things like that. I put here on the additional tools if you want to design diagrams. I like this kind of tools which are code, let's say diagrams as a code. I don't know if this is like that. Rather than use PowerPoint and things like that, you can, let's say, program, and it will be similar. It's not Markdown, but it's text. So you don't spend time trying to align things. It will be auto alignment. It has some constraints and some difficulties sometimes, but for simple things, it's quite effective. And even if you use something like, I don't know, some AI probably can design this kind of diagrams quite easily. Maybe sometimes they do very wrong diagrams, but okay, but it's a start. EventStorming, it's a trend that is using when you want to discover domain behavior and processes. I think there is even a site completely dedicated to this, conference and things like that. I think it's a thing. I never had to do it. I don't know what it is, but I never had to do it, but it seems it's a thing. But of course, domain-driven design, story mapping, this is in Agile, and domain-driven design, please read about this if you are working as an architect. Not only as even developers, the concept of domain is quite important for the developing frameworks, and even for architecture. For instance, microservices tries to follow this kind of approach. What is the domain, and how should you develop your solution based on domains? ADRs, something that I talk about. Markdown, Confluence, Google Docs are also alternatives. You can create always I work in a company that we have a Microsoft Word template with, I'm not exaggerating, 20 pages. But it was an enterprise architecture, so I had to explain everything: networks, flows, the context. I have to explain the strategy, if there was integration in the cloud, how. There were a lot of different topics that I had to address, and some of the topics were not relevant for me to explain them. But at least I should say, no, my architecture doesn't apply to this, because there are a lot of teams in the company, and all of them will read this document and they want to check if they have to do something or some preparation or not. Then there are things like context maps, Wardley Maps, risk matrix. I will talk about risk matrix, I think, in the latest slide or something. No, it will be a different matrix, not the risk, but the risk matrix is related to project management, and I will use a lot when I'm doing architecture. Risk, it's one of, for me, the most important aspects when I take decision on architecture, which is what is the risk, what is the decision that has more impact to the stakeholders, and start from there if you want to build a product or take decisions, because if it fails, it has a big impact. So of course there will be this impact will reflect on the company. So learn about risk matrix. First things like understanding strategy positioning, if it's necessary or not. Maybe you want to do a presentation, you can go Wardley Maps, but there are SWOT analysis quite popular, the strong, the weakness, opportunities, and things like that you can use when you take your decision. But it's highly business. Maybe you can mix business and architecture solutions, sometimes architecture in the SWOT analysis, because there are strong points about your decision, weak points, and you can even create this when you do a presentation to all the stakeholders. Don't make it too technical, but explain why your technical decision has an impact on the business. Postman Swagger, it's quite popular for the REST APIs, as you know. OpenAPI is related to Swagger, of course. GitHub, who doesn't use it today? Docker and Kubernetes, a higher trend. Terraform for infrastructure, to create scripting for the infrastructure. Ansible, it's quite also popular. Prometheus and Grafana, if you are using observability. Not only observability, but Prometheus for the metrics and Grafana for dashboards, it's quite popular. And SonarQube, it's really used for give some insights about the quality of your code. Not architecture solution, but for the code. It's something that I always look for when I'm in a company. Say, okay, where is the SonarQube or similar, to check the quality, the coverage, and things like that, to make sure that the application has a minimal quality. There are other ones like SLint, PMD. PMD, it's to analyze code, for instance, in Java. So let's see, imagine that you have to architecting a system. This is a possible, I think it's a popular architect. It's almost complete here, but so we can discuss a little bit how an architect thinks about these things. So imagine that these clients here, we can have a web app. Imagine that it's developing React, mobile app, and a partner API client that needs, which contains a front end that wants to connect to our our backend. Of course, we have our microservice backend here, and we have this web service microservice with web service, of course, REST APIs, and usually we have an API gateway. And this is a possible architecture. And then we have this infrastructure. And the challenge here is not to explain how did I reach this architecture, but let's see how architect you are when you think that let's see which things do you see here. If you are an architect, you will see something like this. So we have a single entry point via API gateway. And this is really important, the gateway, because abstracts all the addresses inside. You can put security here, cache, throttling, a lot of authentications, authorizations. You can put everything in. You can control almost everything before a request enters in here. You can even forward, you can make load balance, you can make routing. So it's a very popular pattern. And an architect always has an API gateway in mind when works with this system. And if you are a developer, probably you look into other things like what technology is using on the web app, but it's not the first thing that the architect checks. When I look into this, I would say, okay, you have a microservice architecture, and we are using an API gateway, and we have some front ends, and in the infrastructure, we have a kind of observability with OpenTelemetry here. We are using events, probably it's the way these microservices communicate, and of course we need service registry, so one service can look for the other services. This is how I think when I look into a diagram like this. Then I'll go deep if I want to understand better. So we have a single entry point via API gateway, we have a front end and back end. Each service owns its own data because it's microservice architecture. We have to understand this. Maybe you have one database with different schemas, or maybe you have physical Postgres in the infrastructure for each one of these microservices. Async communication is a loose coupling. That's why you have Kafka here. Observability, because we have OpenTelemetry and want to understand what's happening inside of all these services, using logs, using traces, metrics, and things like that. System is modular, and which means that probably it's scalable. It's not it's not because it's modular, it's scalable, but okay, it helps. Okay, we can scale this one and not the others if it's necessary. Okay, infrastructure is shared, but services remain autonomous. Okay, we are sharing the infrastructure. Maybe OpenTelemetry receive everything for all the services, because later we want to correlate requests that goes through all the microservices. But that's infrastructure is shared, but service remain autonomous, which is a good thing. Supports multiple client types. We have mobile, web, and APIs here. Encourage independent deployment of services, because it's microservices. If I want a different one or do an update on this one, of course I have to study a little bit the other. But since we are using Kafka, meaning events, should be easier if I maintain the compatibility, at least of the message format shared between the services, and flavors clear boundaries and responsibility per service. There are other things, but usually these are the things that you can take from a design like this one. If you looking more about what is the technology, which language was used, which SQL is used here, if you want to go into details, you have still a kind of a dev mindset. And if you want to go an architect, try to understand why this is more important. Take into consideration everything I said in the previous slides. And if you start from the first slide, you understand why these things are important, like support multiple client types, its model, the observability, okay, things like that. Okay, encourage independent deployment, which means that we can align better for strategy change in the future when you talk with the business leader, not technical persons. Okay, so define constraints earlier. This is the most important thing when you are developing an architecture. What are the constraints? Because it will make you do trade-offs on your decisions. Okay, and because the constraints shape architecture more than desires. Wanting things doesn't define the architecture. What we can't do defines the architecture. It's the other way around, because we always have constraints: money, people, knowledge, ad hoc, time to market. A lot of things constrain our architecture, and we will make decisions based on these constraints, not based in what we want. Okay. for instance, time to market compliance, GDPR, privacy data, latency latency, meaning how performant do we want our website. I remember that I was studying a specific protocol for a project that I was developing, and one of the requirements that all the latency, the maximum one, should be 100 milliseconds. So it's really constrained, and it will influence a lot the decisions that will be made from the architect point of view, and even the development, because the development should be coded to be fast on the response. You cannot do too many joins in tables and things like that. Maybe you need cache, maybe you need, and we need monitoring to make sure that we never pass 100 milliseconds. If we pass one to an alert, maybe we have to do something different on the system or update the system. That's why it's really important. The constraints, team skill set, it's a constraint, budget, money, of course, legacy systems integrations, it's always an issue. And of course, a good architect works with constraints, not against them. People say, oh, again, constraint, I cannot do this. No, embrace it. Say, okay, maybe now I can take better decisions. I know what I can't use. These are the ones that I can use now on my decisions. So this leads us to the architectural trade-offs, of course. Speed cost, you cannot have both. You want more speed, you need more performance, you need other types of systems, so more cost. Consistency and availability, we can relate this to the CAP theorem, something that I will create a complete video about. It, something that every architect should know, which is consistency, availability, and partitioning. And it's a law where it says that you cannot have the three at the same time. So there is always this trade-off. Coupling versus cohesion, you cannot have both, because when you have cohesion, probably you have smaller models. And if you think for a while, you see that I'm right. And if you have smaller models, probably you will increase the coupling. And if you want a lot of coupling, probably you will have lesser modes, but you will lose some cohesion. It's very difficult to have both. You have to try to balance as best as you can this. And by the way, when you don't have cohesion, it means that when you do a change, you are not changing only your system, but maybe you are influencing something on another system without knowing, because there are code there that belong to a different feature, meaning that there are features that are kind of outsiders in your code, but they are in that model in particular for some reason. So be careful with that. And of course, innovation and stability, you can have both. If you have innovation, you have instability, and your architecture should be designed to allow that frequent changes. So you can create something like a trade-off matrix and plot options by impact versus risk with late decisions. So an example of an architectural trade-off matrix will be something like this. You take your options, you say, okay, how will be, let's say you have a decision about your architecture, say, will we use microservice, monolith, serverless, event-driven, distributed system, single page application, maybe a combination of these ones. This is not exhaustive, just examples. And you say, okay, I want to check the risk, the cost, time to market, performance, and scalability. These are the 5 ones that I want to discuss with the business people. So risk, medium, microservice, it's medium. Cost, high, because there will be a lot of communication between them. I will address them. Time to market, medium. Performance, high. Scalability, high, which is a good thing. But the problem is I have a high cost. Maybe I don't have money for that. So I'll go monolith. Monolith, the risk is quite low. Everything is on the same place. The cost is less because you don't have too many communications between service. Just one service there. Time to market, high. It's quite rapid to develop the monolith. Performance is less than the other ones because you have to optimize, and maybe there will be a lot of code. Maybe you cannot optimize some of the things. Scalability, of course, low. And you can take the same decisions for the other ones. I will address each one of these, let's say, architecture styles, if you want, or patterns, as you wish to call them, in specific videos for each one of them. So how to use the matrix: risk, the potential for failure, or changes in implementation. High risk could mean difficulty in scaling, integration, long-term maintenance. The cost, I think it explains itself. Time to market, how quickly the option can be implemented and deployed. Performance, how the system ability to handle load, latency, and responsiveness under heavy usage. I would say something like elasticity. Maybe I'm not saying this word right, but you can find it when you have peaks, let's say, of loading, and you want your system to stretch and allows all of them without breaking. Scalability, which is highly related with scalability and performance, of course. The ability to scale the system horizontally or vertically to accommodate growing user demand. So this matrix helps to compare trade-offs. And then you can discuss this architecture with the stakeholders involved in which one of these dimensions. Maybe you have more than these ones, depending on the stakeholders. And then you take the decision, and then you decide that in architecture decision record. Okay. So modular thinking from day one, break system into cohesive, loosely coupled components. This is a tip that I highlight here. Favor interfaces over implementations, design for testing and mocking. This is just a modular thinking that you can take from the developer perspective, but you can apply it in architecture also. They are good tips. So it will have a flexibility in the implementation, easier parallel work by teams, clear ownership of boundaries. Sometimes you cannot achieve all of this, but for instance, when you see something like easier parallel work by teams, that's because you are using interface. In architecture. Probably if you are in microservices, it's almost the same concept. It's the message that I want to show here. It's modular thinking. It's always a good thing, but again, it depends on these and the decisions that you should take. I even create one video, I think, in my series about decision frameworks called First Principles, where somehow is related with this part. And I have that series about decision frameworks because I love decision frameworks. It's tools for my thinking and to take good decisions, and they are quite important to know them, because it's like finding as you wish to find the right database or the right technology in your architecture, you need also the right tool or the right decision framework for you to think clearly and communicate your decisions with different types of people. Because one thing is when you want to communicate a decision to a developer, another thing is when you want to pass this decision, for instance, to business people. So anti-patterns, starting with code, no clear problem definition. If you start with the code, you are risking. Maybe you have to throw away all the code developed because the architect can say, okay, we cannot go that way. Copying architect from another project blindly, meaning only because it was a success in our previous architect doesn't mean for a new context and new requirements that we should apply the same architecture. Again, check my video about first principles decision framework. Choosing frameworks before defining constraints, skipping stakeholder conversations, don't do it. You are doing this stuff for them. It is as simple as that. Not document decisions or alternatives. If you don't document, you don't remember why you took that decision and can be challenged, and it will be awkward. Okay. In summary, architecture is a process of making informed decisions earlier, involves people, systems, constraints, and context. Code is the outcome, okay, not the starting point. Early alignment avoids costly work later. Everything is about stakeholders, decisions, trade-offs, constraints, and that's it. That's the best advice I can give you about the difference between the code and when you are targeting the architecture. Being architect, it's different. You don't start with the code, you start with thinking about constraints and things like that, as I show you in all these slides, and then you think about the code. Okay. So if you want some further reading, I have some of these books. I put it here and some sites that I can follow. There are other places you can try to find on internet. This one is quite good, software architecture. The art parts for further research, art of scalability, domain-driven design. Read it. Again, read it. At least read some articles about it. I usually go to this site 2 or 3 times a year. They have the trends, what you should address, things like that. It's a quite nice radar that they have. And of course, if you want to know more about architecture decision records, you just go to this GitHub. They have a lot of examples there. So thank you. Thanks for learning. Code like an architect, as I usually say. Think before you type, meaning architecture comes before coding. And I hope you now understand the why. So thank you for watching. I know these videos are longer. It's about architecture, a lot to talk about, and it's about the mindset. And that's important. If you have the mindset, you understand what is behind, maybe these ideas will enter in your mind and you can be a successful architect. It's my wish, as I try to be one also, with all my failures and sometimes success, but that's how we learn. So thank you for watching. Hope you liked the video. Share it with your friends. Hope it helped you. Left some comments, some subjects that you want for me to address. And I promise you I'll do more practical videos in the future, and I hope in less time than this one. So thank you, and I hope to see you in my next video.